So our project is Precision Mechanics Applications of Metal Fusion Fastening Method, sponsored by ASML. The purpose of ASML Fusion is to create a concept that can replace and or enhance the company's current large bolt fastening method used within their lithography machines. The team is to research different types of fusion and fastening methods, perform testing for concepts, and produce a prototype. So the project scope was narrowed down to in-plane adjustable reassemblable designs. So in-plane adjustable means the top plate can initially be adjusted in X and Y directions. So some important requirements for this system are: it must be operable at high accelerations, it must withstand microslip, have good shear strength, have high resolution of in-plane alignment, along with other things. So for our design, like I said, it was in-plane adjustable and reassemblable with original parts. Cone piece cradles the sphere and is spot welded to the upper plate to fix the system once it's aligned. The sphere's fitting chambers allow for a high degree of repeatability, and it's compatible with a spot welder as seen in figure 5. So the upper plate has clearance holes, and the clearance between these holes and the bolts allow for the top plate to be adjusted. And then the lower plate is threaded, so it essentially fixes the system to allow for adjustment in the top plate. So for our testing methodology, we use 4 optical sensors integrated into the prototype with knife edges, and these were used to test the system's resolution, microslip, and repeatability. And these are accurate within 0.01 microns. So for our results, we tested the weld strength of our welder. And we did this using a static tensile loading machine. And we calculated our average shear strength of 3 welded joints to be 395.86 megapascals. Next, for our resolution of adjustment, we just have placeholders for these values because we haven't done the testing yet, but essentially we're going to pick target voltages for each sensor, and we're going to adjust the top plate through tapping, and then we're going to record how far off the values are from our target values. And then we're going to weld the system and monitor the displacement during welding, so how much the system shifts after you weld it. And then finally, for our repeatability, and we also still haven't tested this yet, but we're essentially going to disassemble and reassemble the system and then measure the offset.